Good morning friends, welcome to Parnika's Tutorials YouTube channel. In the last video, I have discussed the basics of red black tree and what are the rules every red black tree should follow. I hope you have watched that video. If you did not watch that video, I request you to go back and watch that video and come back to this video for better understanding. In this video, I want to discuss the rules in inserting the elements in the red black tree or creating a red black tree. Then I will discuss one example so that you will understand how to insert the elements in the red black tree. First let me discuss all the rules, then I will discuss with a proper example. Now first thing is that if you want to insert any element, if tree is empty, first you need to check whether the tree is empty or not empty. If tree is empty, create a new node as a root node with color as black. Suppose let's take that you want to insert 9 and there is no red black tree right now, means it is empty. If it is empty, then you will consider this 9 as a root node with a color called black. This is what the first point is saying. Now, if tree is not empty, create a new node as a leaf node with color as red. Is it clear? Suppose let's take that now you want to insert 19. Now whether the tree is empty? No, because there is a root node with a value 9 which is black color. Now you want to insert 19. Now where you will insert? It should satisfy the binary search tree property also, because red black tree is a self-balancing binary search tree. So 19 where you will insert? You will insert to the right of 9. And what is the color you should give? If tree is not empty, create a new node as a leaf node with the color red. This is the red color you will give. This is the second point. Now you need to check, once you make it as a red, you need to check if parent of new node is black, it is okay. Now this is the new node we have created. Parent of the new node is black or not, you need to check. If it is black, it is okay. If it is red, then what is the point we have discussed? We have discussed that no two adjacents have the same red color. That is the point we have discussed when we are discussing about the red black tree. So if there is a red conflict, then we will do the corresponding action. But if the parent of the node is black, then it is not a problem. So this is up to creation of red black tree with elements 9 and 19. Now you want to insert 6. Check whether the red black tree is empty. No, it is not empty. It consists of 2 elements. Now where you should insert the value 6. 6 is less than 9, so you insert in the left of 9. Now which color you need to give? You need to give the red color for it. Are you able to understand? And then you need to check what is the parent's color. Parent color is black, then you can leave it. That is the second and third point is saying. Now if parent of new node is red, suppose let's take that here it is a red color, just for example, or you are inserting some more element here. Let's take that you are inserting 5. Is it clear? Now 5 is less than 9, less than 6, so you will insert here. Now what is the color you will give according to the rule 2? As it is a new node which is a leaf, you will give the red color. Now the third point, what it is saying, if parent of new node is black, it is okay. If it is not black, then it is a red conflict. Why it is a red conflict? There is a one rule in the red black tree is that no two adjacent elements should have the same red color. Is it clear? These two are having the red color. So this is a red conflict. If it is so, if the parent of new node is red, then color of the uncle you need to check. What is the color of uncle means? This node is the parent. Now parent sibling will become what? Your uncle. So you are checking the 19 here. Let me repeat again. If parent of new node, this is your new node. Okay. If parent of new node is red, then color of uncle of the parent node you need to check. Are you able to understand? Color of the uncle of the new node you need to check. What is the new node here? This parent sibling is your uncle, or here instead of uncle I can write it as parent's sibling also. So this is the new node, its parent is 6, its sibling is 19, so this is your uncle. Now this is an uncle, then there are the two scenarios are possible. Whether the uncle color is red or black. If the uncle color is black or null, null is also black only. We have discussed that null node we will represent with a color called black. Then do suitable rotations and recolor. If the color of uncle is red, then recolor the uncle and parent of the new node, and also check if grandparent of the new node, if it is not root node, then recolor it and recheck it. These 2 points are little bit difficult to understand. I will discuss with an examples, don't worry. Okay. So now let me erase this one so that you have understood what is the uncle, everything. This is what the red one. Now you want to insert 16. Now check it. 16 is greater than 9, less than 19. So you will insert here. So we will go with our example. Okay. Now it is a new node and we make it as a leaf node. So its color should be red. Am I right or wrong? Now third point is saying if parent of new node is black, it is okay. But parent is 19, which is red color. So now what is the problem is there? Now you need to check the fourth point. If parent of new node is red, yes, it is red only. Then color of uncle you need to check of the red node. Color of the uncle is red here. So if the color of uncle is red, this is the point you need to check. See, the color of the uncle can be black or red. If it is black, we will follow this point. If it is red, we will follow this point. So if the color of the uncle is red, okay, then recolor the uncle and parent of the new node. Uncle and the parent of the new node we need to recolor. Recolor means if it is red, we will make it into black. Recoloring means if it is red, let me write this point. If it is red, we will recolor into black. If it is black, we will recolor into red. This is the point I want to discuss here. So previously it was red, so I made it into black. Now this uncle color is also red. I will recolor into black. Is it clear? Now you need to check another one and also check if grandparent of the new node. What is the new node? This is the new node. What is the grandparent? This 9 is the grandparent. If it is not root node, then recolor it and recheck. Now in our case, this 9 is the root node. So if it is root node, we no need to recolor. That is what they are saying. If it is not root node, then recolor it and recheck it. But in our case, this 9 is the grandparent of this 16 and it is a root node. So I no need to recolor it. So now this is a red black tree after inserting up to 16. Now I want to insert 18. Where 18 will come? 18 is greater than 9, less than 19, greater than 16. So we need to insert here. Are you able to understand? Now it is a new node and we will make it in a color called red with the second point. Now we need to check the third point. If the parent of new node is black, it is okay. But here in our case, it is red. If the parent of new node is red, then check the color of uncle. What is the uncle? This is our new node. Let me write here so that you will understand. This is our new node. Uncle is what? This is the parent. Uncle is nothing but its sibling. Am I right or wrong? Or this is the sibling. Am I right or wrong? This is not a sibling. Sorry for it. This is the parent and its sibling will be this one because 19 child is 16 and this one. So this is the uncle. Now I already discussed that if you have a leaf node which is null, then it will be black color. I said this point or not? In the last video we have discussed it. Even here also I have written if it is null, if it is either black or null, but in our case it is null here. So uncle color is black because it is a null, so it is black. If it is black, then what they are telling? Do the suitable rotation and recolor it. Do suitable rotation. Rotations means already we have discussed when we are discussing about the AVL tree, such as LL rotation, LR rotation, RL rotation, RR rotation. So we need to check which rotation we need to follow and do accordingly. Now how can I identify which rotation I need to follow? This is the new node. So you need to traverse from here. Is it clear? You need to traverse from here, which is left, and then you have a right. Okay, are you able to understand? Left and right. So you need to go for the LR rotation. LR rotation is what? You need to go for RR rotation, then you need to go for LL rotation. So let me go for the RR rotation and then LL rotation on this one. So if I take 19, let me write here, then I will represent the colors. First let me do the LR rotation. You have a 19, 16 and 18 is there. So if I need to do the LR rotation, first I will need to do the RR rotation. So I have a 16, I have 18, I will take one dummy element, then I will do the RR rotation. When I was discussing about the AVL tree, already I have discussed what is the use of this dummy element. It will be useful for us to simplify the rotation of LR rotation. Suppose if I want to do the RR rotation, I will hold this 18 and I will move this 16 towards the left side. Then I will get it as, let me write here, I will get 18, I will get 16 and you will have a dummy element. Am I right or wrong? Now we need to insert this 19 and then we need to do the LL rotation. Is it clear? Now the need for the dummy element is completed. Are you able to understand? So first if I need to do the LR rotation, first I need to do the RR rotation, then LL rotation. Now if I do the LL rotation, I need to hold this 18 and I need to move this 19 towards the right side, then I will get here. So I will get like 18, 16, 19. Okay, so in place of this entire one, you need to keep here. Now you need to check one more important point. What is the color of 18 is red right here. What is the color of 19 is black. What is the color of the 16 is red. Are you able to understand it or not? Let me repeat again. This color is red. This color is black. 19 color is already black. 18 color is red. And 16 color is red. Now you need to recolor these two. Are you able to understand? If and also where is this? Yeah. Do suitable rotation and recolor. So you need to do the suitable rotation and you need to recolor this one. Red and black you need to make it as, this is red, you need to make it as a black, and 19 is black, you need to make it as a red. 16 is already red, you can leave it. Meaning is that 16 you should not recolor. These two you need to recolor. Is it clear? Slowly you will understand with few more examples, don't worry. So first thing is that I need to remove this one and I need to keep 18 here, okay, 16 here, 19 here, 18's color is black, okay, 16 color is red, 19 color is red. Now you need to check whether the properties are satisfied. I am damn sure that all the properties of red black tree will be satisfied. Now what is the first property of a red black tree? All the nodes either should be red color or black color. Each node I have represented either with the red color or black color. Then what is the second point? The root node should be black in color. Yeah, good. And there is third point is that there should be no two nodes which are adjacent with red color. Now if you see it, these two are not adjacent, these two are childs or the siblings of 18. Okay, sorry, childs of 18. So they are not the adjacent nodes, so there is no adjacent red. Okay, and the fourth point is that from any node including the root, if you are going for any descent null node, if you are going for it, how many black nodes are there? There should be same number of black nodes. Suppose if you are coming here, you have two black nodes. If you are coming here, because after 6 only you will have the null nodes, am I right? Here you will have null node, here you will null have, all these things are the null nodes. The null nodes we usually will not represent, but to check the property. Now how many black nodes? 2 black nodes. Here also 2 black nodes. So same number of black nodes are there. So I can say that it is satisfying the red black tree properties. So we have successfully inserted up to 18. Now I want to insert 25. Now 25, where should I insert? 25 is greater than 9, greater than 18, greater than 19. So you need to insert to the right of 19. Now as it is a leaf node or for a non-empty red black tree, we are inserting 25. So you need to look at the second one. If tree is not empty, create a new node as a leaf node with color as red. Okay. Now check the third rule. If the parent of new node is black, it is okay. But what is the parent? Here 19. 19's color is red. Okay. Let me write here so that you will understand. 25's parent is 19, which is red color. So if parent of new node is red, then color of the uncle of the new node, you need to check it. What is the color of the new node's uncle? This is the new node. Okay, this is your new node, whose uncle is this one, because this is the parent and parent sibling is the uncle. If the uncle color is red, okay, then recolor the uncle and parent of the new node. Now recolor the uncle. Uncle's color is red. Now I am modifying into black. And also parent of the new node. Parent color previously was red. Now I am recoloring and making it into black. Now this is okay. Now also check if grandparent of the new node, this is the new node, grandparent is this one. You need to check whether it is a root node or not. It is not a root node because root node is 9, but this is the grandparent, so which is not a root node. If it is not a root node, then recolor it and check it. Then recoloring means it is black. You need to modify into red. Now you need to check after making it into red color, do you got any red conflict? No, you did not get any red conflict, then you can leave it. If you get a red conflict, that is what the recheck, then do the appropriate action. Okay, here you can go for the 4A point or 4B point. It depends on the color of the uncle. So after changing this black to red, there was no red conflict, so I can leave it. Is it clear? Are you able to understand? So we have successfully inserted up to 25. Now I want to insert 40. Where is 40 should be inserted? 40 is greater than 9, greater than 18, greater than 19, greater than 25. So here you will insert 40. Now you need to make it as a red color. And the parent of the new node, this is the new node. Okay. Parent of the new node is not a black. If it is black, I can leave it. If it is not black, then meaning is that there is a red conflict. If it is a red conflict is there, you need to check the new node's uncle, which is a null node here. Am I right? Because there is no node, so which is a null, which is black in color. Are you able to understand it or not? All these points I have discussed in the previous video, which is a black. So then what you need to do? If the color of the uncle is black or null, then do suitable rotation and recolor. Now do the suitable rotation. Suitable rotation means come from this 19. What is the new node? 40. So how you can go? You can go to the right. You can go to the right. So you need to do the RR rotation. Okay. First let me do the RR rotation. If I do the RR rotation to the 19, 25 and 40, if I do the RR rotation, I will hold this 19 and I will move this 19, I will hold this 25 and I will move this 19 to the left side. If I move the 19 to the left side, I will get like this. Okay. And then check it, always please check it. What is the final rotation you are doing here? RR is the final rotation, because when you are discussing about the LR rotation, we have done RR and then LR. Okay. Now whenever you are doing the final rotation, in this case only this is the one rotation is there, you need to check the this one and this one color, and you need to recolor them. Previously it was red. Let me write here red. 19 was the black previously, and 40 is the red. Are you able to understand? Now you need to recolor them. Okay, let me erase it. Recolor the 25 and 19. 25 will become, previously it was red, now you have to make it into black. And 19 was black, you need to make it into red color. And 40, previously red, you can leave it as red. Are you able to understand it or not? Okay. Now, is it completed? Do the suitable rotation, and also we have recolored. If you want to cross check, you can cross check how many blacks you are getting. Now if you are going like this, you are getting 2 blacks. How many blacks if you are coming here? 1, 2, 2 blacks. If you are going here 1, 2, 2 blacks are there. If you are coming also here 2 blacks. So same number of black nodes are there. If you are going to any descent node, you can cross check it. This is the red black tree after inserting 40. Now let me insert 90. Where I should insert 90? 90 is greater than 9, greater than 18, greater than 25, greater than 40. So I need to insert 90 here, because it should satisfy the binary search tree property. Now again you need to check this is the new node. Will you agree with me or not? Now new node's parent is not a black node. If it is black, I can leave it. As it is not a black node, I will check the uncle's color of the new node. Uncle is this one, which is red. If the color of the uncle is red, then recolor the uncle and parent of the new node. Recolor means, as it is a parent whose color is red, now I will make it into black. Uncle's color is also red. Now I will recolor into black. And again what you need to check, and also check if grandparent of new node is root node or not. This is the new node. What is the grandparent? Is 25, which is not a root node. If it is not a root node, then recolor it. Recolor means it is black. Now you modify into red color. Okay, are you able to understand? And then recheck it whether any RR conflict are there or not. Here there is an RR conflict. Are you able to understand it or not? This is the RR conflict is there. Now which is the color you have modified? You have modified the 25. So RR conflict is there. Now if it is an RR conflict is there, this uncle you need to check. 25 is the new node now, because whose color is modified now. Let me write it here like this so that you will understand. Now 25 color was previously black, you modified into red. Now this is your new node which has created the RR conflict. Like that you can write, easily I can understand. Now new node's uncle. Where is the uncle? This is the parent. Parent sibling is this black. If color of uncle is black or null, then do the suitable rotation and recolor. Suitable rotation means this is the new node, so you need to go for this is R and this is R. So you need to do the RR rotation. Okay, if I do the RR rotation, how it looks like? Which one I will hold? I will hold this 18. If I hold this 18, then this 9 and 6 will come to the left side. Am I right or wrong? If I hold this one, if I am doing the RR rotation, then 9 and 6 I need to move it to the left side. Then 9 and 6 you have a 16 here, which is color is black, because colors are also very important for us. 9 color is also black. So 9 will come here, which is black in color. I will write with B. And you have a 6 whose color is also black, which I am writing as B. And you have a 16. 16 where it will come? Here 16 will come. So I hope you know that the rotation. So that's why I am writing directly. If you don't know how to do the rotations, I request you to watch my previous video on AVL tree. There I have discussed about the AVL tree rotations. Okay. So there is an rotation need to be performed, then we have moved the left. So this is the point. If the color of the uncle is black or null, then do the suitable rotation and recolor it. Previously, what is the node here? It is there, 9 is there, which is in black. Now you need to do the recolor for these two nodes. Is it clear? Finally, what rotation you are doing, then you need to look at this top two. Then you need to recolor them. Here it was red, now you need to make it into black. Okay, now 9 was black, you need to make it into red. So after inserting 90, we got this one. If you want, you can cross check it, whether it is red black tree or not. Okay, let me remove this one so you can write this final answer. Now if you want to cross check how many nodes black nodes are there for each traversal, if you look at from the root node, you can check it. If you want to go to this null node, suppose let's take that which is a null node. If you want to go there, 1, 2 black nodes are there. If any null node is there, you will visit 2 black nodes. If any null node is here, 1 black, 2 black, so 2. If any null node is here, 1, 2, and here also 2. So same number of black nodes you are visiting, and there is no RR conflict, and the root node is black in color. So this is the red black tree after inserting the above elements in a sequence order. So I hope you have understood how to insert elements in the red black tree. If you still have any doubts, don't worry, I will take another example and I will discuss in the next video. Thank you for watching the complete video. Have a nice day.